Ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for today's event, in which we're going to talk about some technology that's been around for a while, but it's got some new twists, and I have to say, it's a technology that was innovative when it first came out, and it sure feels like its time has come in a pretty serious way for a whole variety of reasons. So we're going to talk about the NonStop Enterprise. Yes, indeed. So let's move through our slides. There is a slide about yours truly and enough about me. So the mission, as many of you know, in the briefing room is to reveal the essential characteristics of enterprise software. So what we do is we basically bring analysts together with vendors, and we conduct live briefings for the benefit of a virtual studio audience. So the vendor and the analyst do not coordinate before the show in order to kind of preserve that organic conversation that occurs when analysts take briefings. So the whole purpose is to really let you get under the covers and see what these technologies are, how they work, and why they work a certain way. So this month, October, is database. We've had several great events already. You can always find them in the archives at insideanalysis.com. Next month is cloud, then innovators, and big data is in January. You can see the list coming up. So let's face it, the database is the foundation of information management. And in the last couple of years, we have seen just an absolute tidal wave of innovation in the database market. All this NoSQL stuff, of course, new SQL. But let's face it, SQL, the structured query language, is almost assuredly never going away. It's a very, very powerful standard that's been agreed upon and used now for many years, and it is pervasive. So it's very useful for being able to wade through large amounts of data, to align information systems, for example, and to get the answers that you need from the systems where they reside. So that's what we're going to be talking about today. Our analyst is Chief Analyst Robin Bloor of the Bloor Group. Very happy to have him online today. Of course, Hewlett-Packard, wow, established in 1939. Hewlett-Packard specializes in developing and manufacturing computing, data storage, and networking hardware, as well as designing software and delivering services. And you can see on the slide here, and also if you've just been paying attention, that obviously HP has been expanding its offerings. And one of those offerings is the HP Integrity NonStop, a platform aimed at mission-critical customers. It includes an integrated stack of hardware, operating system, database, etc. So Ajaya Gummadi is going to be joining us today. She is the database product manager with the HP NonStop Enterprise Division. We're very pleased to have her expertise on the line. And with that, I'm going to hand her the keys to the WebEx, and she'll be on her way. Ajaya, the floor is yours.
Thank you, Eric. And if I remember, I have to click here, and then, great. I'm all set. So I am Ajaya Gummadi indeed, and I'm here to talk about one of my favorite databases, NonStop SQL. In the next few slides, let me show you why it's become so critical to have a database that's aligned with your business. So this is a question that's very unusual for NonStop customers. Like businesses, ITs go down, really? Actually, we are very happy that the world is finally moving to what our sweet spot has been forever, for 35 years plus, when NonStop servers were brought to the market. It doesn't matter what you're doing it, how you're writing your apps, what they're delivering. The key thing is that your application, your database needs to be available for your business all the time, at all times, okay? And with HP NonStop, it is. It is to our existing customers, and it will be for all the customers who engage with NonStop. It is the platform recognized for continuous business. It was designed, both integrated hardware and software, with continuous business processes in mind. And it's been delivering that for 35 years. And when we say platform, it's not only the hardware. Hardware, as we know, has become more and more reliable. We are talking the whole stack. We are talking the operating system kernel, the database engine, and the application all of it to be continuously available. And NonStop does all that with the lowest total cost of ownership, and it plays very well in the mission-critical environment. So what do I mean when I say mission-critical? From our perspective, a mission-critical environment will have no interruptions to the application or the business process, okay? It got to be available always. And when we say it's got to be available always, we got to look at anything that impacts the availability of your application, whether those are transactional applications that are processing orders from your customers, or running the distribution application to move stuff to your data warehouses, or your BI applications, okay? When we say mission critical, we want customers to experience their businesses up and running at all times, no excuses whatsoever. And HP has a long history of supporting customers with the NonStop servers with their mission-critical needs. So HP itself was formed in '39. NonStop came out with its first server offering in, I think, '76, '74 time frame. I say that before I was born, just kidding. But it's been there right from the day zero. It's in the DNA of NonStop servers. And you folks may be already aware the cost of downtimes, but when you look at these numbers, they just strike you, okay? The cost of this, having your business unavailable is huge. It's measured in millions of dollars, and sometimes it makes it to the headlines, and you don't want your business to be in the headlines for the wrong reasons. So any investment that our customers make in NonStop pays off not only in uptime, it helps you sleep, the operations folks, better at night, but more importantly, it keeps you off the front pages of newspapers, okay? So here in the financial industry, it's huge, $16 million and plus. And in just last 1 year, some of our banks in UK, like the HSBC and RBS, and by the way, they don't run on NonStop, and the subsidiaries, First Direct and NatWest, had huge, huge IT-related service outages, and they lasted for days. What did that mean? What that meant to me as an end customer was I wasn't able to use the cash machines from HSBC or RBS. I wasn't able to do mobile banking. I wasn't able to do online banking for hours and hours together. And from the bank's perspective, they had huge transaction backlogs and millions of dollars lost. So that's the cost of downtime that's there, and it reflects across the industries, not only just in the financial, but in retail, healthcare, manufacturing, all of those industries. It's immense. So you would like to pay attention to a platform that can have your business up and running at all times. Now let's look at things from the perspective of data, okay? What's happening here is a huge revolution, to say. There's just an enormous amount of data getting generated today from all types of sources. There was a recent report from IBM saying 90% of world's data has been generated in the last 2 years. And of course, we all are contributing to it with our Facebook likes and tweets, and of course, the system-generated data, okay? From the sensors, from the RFIDs, from the alerts, from the web logs. The numbers, the ratio of structured transactional data to unstructured data, it may vary. Some people say it's 60-40, some are saying 70-30, but everyone is agreeing that the trend is to go more and more towards unstructured data over the coming few years. There will be a lot of data all around us. It will be coming very, very fast at us, and it will need to become meaningful almost as soon as it gets generated. So these are the changes that we are observing in the market. What will this need from a database engine? Okay. Your database engine from your vendor will need to provide performance, scale, capacity at an optimal price point with low complexity. Not much to ask from a database engine, right? And when we say performance, we mean not only ability to handle more throughput, but also with better response time. The scale, the data would be petabytes, zettabytes, whatever the next bytes come after that. The users will be millions, not the thousands that started in 70s for online applications. The types of application will be varied, but one thing will be underneath all of those, and that would be these will be real-time applications. They will need to act on the data in real time. They will need to have the efficiencies out of the box, no complex configuration, not many people resources being thrown at the database engine to make things happen. And it will need to keep looking at the cost and reduce them while improving the service level agreements to the end IT users. So what you need to make as a database architect or information architect to these days, you have many choices. You can choose between commodity servers or special purpose hardware, relational database or non-relational database, a server in a private cloud or in a hybrid or public cloud. Do you want to go with an in-memory database or still the disk-based or combination of both? Uncompressed data to access it quickly or compressed data to reside on cheaper storage? How do you want to split your data, range or hash partitioning, one server or more servers in a cluster? How will you improve the performance of your database? Stay with row store or go with column store? So all of these things are being taught by the information architects. In fact, if you read the recruiting blogs, you'll see being an info architect will be the most sought after skill in coming days. So you are at the right talk at the right time, this being the database month in the briefing room. Okay, so this is where HP's NonStop SQL comes in. Okay, it not only comes in, it's the sort of a diamond shining up there. Well, we have been using integrated hardware and software for only 37 or plus years. Okay, we have always been cluster aware out of the box, no added software or hardware to order and install separately. It comes with the server. We are also out of the box mixed workload capabilities. We offer those. The data can be virtualized. The query execution can be virtualized. We support ANSI standards, 99 fully, 2003 partially, and we also support the ODBC and JDBC standards. And then in addition to that, NonStop SQL can also support Oracle syntax, the Oracle extensions to ANSI syntax so that you can bring your Oracle database app to NonStop SQL. The routine DBA functions, they can be managed online. And then it's fully aligned with the NonStop kernel in its takeover and massively parallel processing architecture. Okay. The NonStop servers themselves are highly fault-tolerant machines. They are continuously available, and that's how they were designed. So at the design time, we paid attention to how can you keep the server online while doing upgrades, software upgrades, or part repairs, online reconfiguration, online management, because these are the things that will help keep your services available at all times. Okay? We can move applications while they are still running, and we can reconfigure and repartition the database while it's still online, while it's still handling the transactions. Okay? I'll show you on a subsequent picture how each processor is its own unit of work, how data is partitioned across all the disks. Okay? Queries are divided into operators and subtasks, and all of them can run in parallel. And as I said, we do handle mixed workload, and we handle online database operations. As far as scale goes, NonStop servers can scale to 4,000 processing nodes in a cluster, or close to 16,000 cores in a cluster. Okay? And then you can sort of scale your workload across the entire cluster. We have NonStop kernel, which is the core at our server, the brain, and then we also provide open system support through POSIX interfaces. With applications, we support Java, we support the SAS stacks, the Hibernates, and all of these work with the online real-time database that's NonStop SQL. So here is a picture of a processor. Each processor or processing node would have a disk process, which will handle the data resident on the disk. It has a SQL executor and a connector process, and underneath there is the operating system kernel. And then these processing software on processing nodes just keep replicating across the entire cluster. And that's what makes us linearly scalable. So we are a shared nothing architecture, and we scale linearly at a rate of 98.5% plus, because it's a shared nothing architecture. Okay. The query itself, as I promised I'll show you, there's a lot of parallelism that we support. The query itself can be divided into operators that can be executed concurrently. There is pipeline parallelism, where the output of one operator can be input to another, and all of this can be handled concurrently. So the data itself gets virtualized across all available storage, supporting range and hash partitioning. On the availability side, coming back, because that's the key differentiator for NonStop, we have designed our operating system and the entire stack to be fault tolerant from day one. So no single point of failure impacts the system operation. Every software process uses something called checkpointing. We run those in process pairs, and they checkpoint the current state and before changing the state to the backup process. So the backup process can take over any time, become the primary process, and start another new backup process in another processor. Okay? And all of this is transparent to the application. The application doesn't need to do anything to avail this benefit of continuous availability. We do it for you in our engine. Cool, huh? As I said, NonStop servers are a shared nothing, loosely coupled architecture, unlike the SMP architecture that's more popular out there. So that's why we can provide the availability as well as the scalability. Okay? Now, I can't show you the animation in this slide, but basically what I'm trying to show here is that the processes are checkpointing, and if the primary process goes down for any reason, the redirected SQL operation will continue to take place on its backup process. And then if that goes down, then the new backup that was created will take over. So it's not a failover architecture, it's a takeover architecture, and that's built into all the components. And we have been in this availability business for only 37 years. That and the scale and the linear growth in scale are the two main reasons why customers are buying NonStop servers and database. It's not something that we do at our high end of the product lines. It's something that's in our DNA across all the servers, okay? So It's very, very important. It's in our DNA, as we would say. Let's look at why people are deploying NonStop SQL in their environment, some of the proof points from recent time. This customer is running a database that's only petabytes, a few hundred petabytes, and has only 2 database administrators managing this environment, and has had no downtime since 1995. So much so they must have forgotten how to cold load the machine. Another customer adopted NonStop SQL on NonStop Server because the cost of downtime was so high for them. Costed them $3 million an hour whenever they experienced an outage. So they have come on to NonStop, have been running without an outage for the last 3 years. Another customer has been managing hundreds of terabytes, so not a huge database when you compare it with petabytes, but again, no outage for last few years since they went live. Another customer, 150, not so big in today's world. What's unique about this customer is the way they are utilizing the mixed workload benefit of NonStop SQL. 39,000 inserts, updates coming in against the database every second, okay? And that data needs to be made available right away to the consumer. They don't have time to replicate the data to another server and then run the OLAP queries or dashboards against that server. They want to see the data right away, okay? So that's why they are using NonStop SQL. And as they are doing the updates and OLAP queries against the database, they're also doing database archiving and some online partition management against the database. So very, very, very cool story about how customers are using NonStop SQL. Another customer from the securities industry moved to NonStop SQL. Again, the key reason was availability and the total cost of ownership. And their objective was they don't want any unplanned outage, okay? Now, the workload-wise, it's not a huge workload scale. 2,000 TPS, it's pretty small, but the cost of downtime to them was so enormous that they had to move to NonStop SQL. Another customer, now this is more around how NonStop SQL is being accessed from modern application interfaces. So this customer is consolidating multiple databases into an operational database data store, okay? And they are running their applications coming in over SASH and ODBC and JDBC interfaces. The application itself is running in cloud in a Tomcat container and accessing the NonStop SQL at the back end. So very cool modern standard story for NonStop SQL. Okay. Our customers love that we have taken the complexity out of their application. All the clustering, out-of-the-box features, those are all available from the SQL engine. Okay. There's no add-on stuff that they have to do to get the benefits of clustering, to be available, to be online. Okay. Just a quick data point, from the time you get the software media for NonStop SQL, there are only 19 steps before you can start using the database, creating schemas, querying the data, inserting data, and all of that. The database itself across the entire cluster gets presented to the DBA as a single image. It doesn't matter whether your cluster is running over 256 cores or 4,000 or 16,000 cores. It's still a single image presented to the DBA, and that gives you a hint why the total cost of ownership is so low. NonStop servers as well as the software support online reconfiguration, so you don't need to bring down your database as you're adding new disks or new servers because your business is experiencing growth. So that's another cool thing about our database. We have a lot of flexibility how customers want to start. They can start as small as a 2-core or 4-core server and scale to thousands of core. Same thing on the user data. They can start as small as 146 gig and scale to petabytes of database. And we don't put any constraints on how they go around growing the server in response to the growth in their business. It's totally up to them. There is lots of flexibility on the scaling dimension. Okay. All our productivity tools that the DBAs love and needed to do their job are included in the SQL license. Whether it's diagnostic or tuning or management, everything is all inclusive, single pit to product to order, single install, and that helps customers as well. So that's another key thing about the product. I may have overrun the time here, so let me stop here. So we think we have a very strong value prop around availability and scalability, integrated platform, cluster aware, ANSI standards, mixed workload, and we have very, very strong proof points from customers. We have a strong roadmap. HP is continuing to invest in NonStop SQL. I love this picture because it shows that we are ready for a takeoff, and that's exactly how I feel with the NonStop SQL product from HP. So I'll thank you, and I'm here to answer any questions that you may have.
All right, let me go ahead and give Robin the keys. Actually, I'll take it back for a quick second, and then we'll get Robin Bloor in here just to give his presentation. So there he is, and that's the first slide. So, Robin, with that, I'm handing it to you, and the floor is yours.
Okay, Anatol, thanks for that. I guess, given that we're talking about NonStop SQL, this is a database that I've known for a long time. I mean, I knew it when it was the flagship Tandem database, and of course, Tandem was eventually acquired by HP through Compaq. So I've been aware that the architecture of NonStop SQL is actually different, and different in many ways. It's closer to the hardware in a number of ways than most databases ever used to be. So what I thought I'd talk about today is just database diversity and home in on what I think is the fulcrum of where NonStop SQL is able to differentiate itself. But then I'll go back and ask questions, and hopefully I'll be set right or corrected or whatever in anything that I've said. I mean, the first thing that's worth saying is that there's always been diversification of the database market. Even in the years in the kind of late 90s when it came to be dominated by Oracle and DB2 and Microsoft SQL Server, there were still hundreds of database products in actual fact of various natures. Some of them differentiated themselves really by focusing on niche areas. In fact, I think that's what most of the ones that survived from that time still do. But we have run into a world where the diversity has increased even more dramatically. A lot of this has been provoked by growth in data, and that has gone hand in hand with the fact that a lot of the older database architectures are no longer appropriate for the kind of workloads that the big data stuff can create. So let's just talk about the whole big data thing. I mean, nowadays, when you actually hear vendors talking about big data, they talk about 100 terabytes up to the petabyte level, or tens of petabytes, or even I think up to 100. I'm not really sure what the biggest database in the world is, but it's certainly in the probably 3 figures of petabytes and growing. But there's actually nothing surprising in this. Corporate data volumes, if you take a trending over the past 20 years at least, then corporate data volumes have been growing at 55% per annum. And 55% per annum means that data volumes grow by a factor of about 1,000 every 6 or 7 years. It's a huge growth rate, And it's also been true of very large databases. The large databases that you hear about in terms of somebody's created a massive heap of data. That kind of figure is growing at about 55% per annum, which also means that it will grow by a factor of about 1,000 every 7 years. So we're looking at petabyte databases right now. We will be looking at exabyte databases in about 3 or 4 years. It won't stop unless there's in some way or other the industry no longer finds more data to gather. So it's called big data now, and I like to think of it as Frankendata. If I can call a big hurricane a Frankenstorm, then I'm going to call this Frankendata. But basically, what's happening is that this is something that the industry has, to a certain extent, got used to, and then something kind of happened, right? And what kind of happened was that the data got so large that it became possible for entirely new database products to arise that focused on very large heaps of data, most of them. So I'm kind of going to run through these. The traditional RDBMS is a traditional OLTP, or it's a data warehouse kind of database. It scales certainly into the terabyte area, but once it gets beyond the terabyte level, the traditional RDBMS kind of runs into problems, and the reason it runs into problems is it scales up, but it doesn't scale out. It doesn't scale out well across what I would call grids rather than clusters, although the word cluster and grid are often used interchangeably. We got the object databases they were used for objects and for OLTP. Very fast at OLTP, much faster than the RDBMSs. But there are only a few areas where that speed was kind of needed. So the object databases found themselves a life there. The column stores were almost like the Empire Strikes Back for the relational database. They're effectively relational databases, but they're fundamentally built for scale out. They're not built for OLTP. None of them claim to be able to do OLTP in any meaningful sense. Some of them even violate the basic atom requirements of a database. And what they do exceedingly well is scale out analytics, but they do scale out analytics well for structured data fundamentally. Then you've got the big table stores, and these are stores are actually only one table, but the table is one huge, massive log file or a huge collection of sensor data. And they're a bit like column stores in the sense that they use a lot of the same techniques. But what they're actually majoring on is the fact that you will not be doing any joins in any meaningful way, and therefore they can streamline the whole of architecture, not to have any joins involved. We've got the NoSQL DBMSs, and the ones that I haven't talked about in terms of NoSQL, because big table stores are also thought of as NoSQL. Those really are about documents and objects, but they're about huge, big heaps of them. And then we've got this category of mixed workload DBMS, into which NonStop SQL falls, in my view. It's large-scale OLTP has always been used for large-scale OLTP, set records in its time. I have no idea whether it still holds records in that area. But it's able to do data warehouse and analytic type of applications off the same data. It's also, I've seen it used in the financial sector for what you would call real-time applications. So when I'm talking about, OLTP and data warehouse at the same time, or probably better to call it an operational data store at the same time, but, when you're talking about that, you're talking about real-time BI. You're talking about, if you're setting up dashboards, for example, the dashboards are responding in real time to what's going on, and therefore you've got absolute up-to-the-minute data. And also you can push analytics across this stuff simply because it scales out so dramatically. So the thing to say is, like, okay, if you're going to buy a big engine, you're going to pay big dollar money for it. But there are some interesting data flow issues. If you look on the left side of this diagram I've put up, you can see OLTP applications and BI applications. firing off the same database, working within the same cluster of processes. Oh, and that's kind of something that's, with NonStop SQL that I kind of find interesting, is you've not only got a fail-safe capability with NonStop SQL, but if some of the nodes are actually running applications, they'll be fail-safe too. So the uptime isn't just the database. If the application in one way or another fails because of any kind of hardware glitch, then it'll flip over immediately. So that's what you get on the left-hand side of the equation. On the right-hand side of the diagram here, what we're actually seeing is what happens when you can't scale up in that way. So you actually start segmenting out the applications. You end up with multiple databases. You end up with data integration. You end up with, if you're going to have an operational data store, if you can manage it, it isn't going to be as fast, and you end up with BI applications running off operational data store. In other words, you end up with a more complicated environment when you go large. Just kind of summarizing all of that, fewer databases can mean fewer points of failure. I mean, when you have a multiples fragmentation like that, then you're actually buying yourself the possibility of multiple points of failure, or the need to dual up everything in a way that allows one thing to fail over to another. It can mean a lower DBA overhead simply because the DBA is capable of looking at all of the data, but that's not just the heap of data. The DBA isn't required for other databases because a lot of it is put together. So it's kind of difficult to work this out in terms of exactly what difference it would make if you kind of went large in this way. But it will make quite a large difference to the DBA workload, depending on how good the database itself is. It means much simpler recovery. Basically, in the non-stop situation, it means never having to recover. But I suppose, if you had an airplane land on the building, then and you were dualed up over the line, then maybe you might have to do a little bit of recovery. But because everything's dualed, recovery is really a very simple thing in the event of any failure of anything. It's automatic, and you see almost no loss of service. It's really very likely to mean much lower latency for BI applications that are running off a mixed workload database, simply because they're hitting the latest data. It depends on how that's been built as to how late, how close it is to real time. But you get towards what I would call near real time. It can mean lower software costs. That's simply because you aren't buying lots of fragmented pieces. You might be paying a big dollar price for one piece, but that's kind of all you're paying. And all of these advantages multiply if you move them out across the data center. But, a mixed workload database doesn't do everything. And actually, that's kind of what I'm going to talk about in terms of the questions I'm going to ask, because I think the area to focus on in terms of questions for this product is really, where is it appropriate? What does it simply not do? So the first question that I've got really for Ajaya is, what do you believe are the absolute technical uniques of NonStop SQL? And I'm kind of differentiating from the fact that, with a lot of databases that claim to do very large workloads, they claim very high availability. They don't claim non-stop. They do claim very high availability. And they claim low DBA overhead and other things like that. So the first question, Ajay, is what would you say were the absolute uniques that NonStop SQL's got?
Right. So as I said, NonStop SQL is fully integrated with underlying NonStop kernel and the disk process stack and the transaction monitor. So this is the only database that runs on NonStop server, and it runs only on NonStop, no other platform. If you remember, NonStop platforms themselves have been architected with a shared nothing, massively parallel takeover architecture. So has NonStop SQL been. So NonStop SQL the executor, the connectivity services, the disk process. They run in each processing node, and they get replicated. They virtualize the data and the query. The mixed workload that we offer with NonStop SQL is because we are integrated with the NonStop kernel, and we use the kernel scheduler to differentiate between short-running queries, long-running queries, and the kernel assigns a priority which helps the SQL engine to deliver mixed workload. On the availability side, the SQL processes have their own backup processes. They checkpoint the state before making the change so that as soon as a transaction comes in and they're about to act on it, both the primary and the backup process knows what's going on with the transaction. So during the course of the transaction, if any component fails, whether it's a hardware component or a software component in the SQL stack, its backup process will take over and start executing from there. So you don't have to ask the end user to resubmit the transaction. That's something very unique about us. The way the executor process decides the level of parallelism and spawns other executor processes, and the way these executor processes work closely with the disk process so that each disk process is looking at the data that's resident on the disk being controlled by them. And then some of the operators like the sorts and the joins get down all the way to the disk process. So instead of pulling data across the interconnect fabric, it's coming from the local disk to the SQL executor, which is then sent over to combine the results of the join or the sort or the group. So we have architected the engine very closely with the fundamentals of the platform, and I think that's what makes this a unique database.
Yeah, I mean, I would say, you know, in terms of the other, let's call them high availability big data products, I would say that they have got it within at the database level, but they absolutely haven't got it at what you would call a kernel level. It isn't close to the iron in that sense. And that is a differentiator, there's no question about it. Some of the other nuances you went into there, I think, are kind of interesting. Once you've got an ability at a very low level to deploy workloads across many, like I kind of think of them as operating resource spaces, you know, many spaces, then it gives you an awful lot of possibility in exactly how certain things are dealt with. And of course, you mentioned query, and big query, especially when SQL requests involve lots of sorts over lots of data, then exactly how you distribute that workload and how you master it is kind of key. But I don't think we're going to be able to go into any great detail of that. But one of the things I'm interested is, you know, and it's just along the lines of the second question is, what mixed workloads are possible with NonStop SQL? Because I've witnessed fairly, what I would say, close to real-time implementations of this technology. I've certainly seen mixes of OLTP and normal analytical BI type applications going on. But, you know, is there something you can speak to that in terms of?
Yeah. Oh, yeah, love to. So different customers, lots of examples of what's going on in the real-time world. But our customers, and I had a slide on one application where a customer is doing database updates and having that database available for queries, OLAP type of queries in real time, without having to replicate the database somewhere else and then run their OLAP query against the replicated database copy. A lot of customers, very typical workload is that they will run their dashboards, run the reports against the updated database. That's a very, very common use case. what I'm seeing more and more is with the real-time world, as your transaction is coming in, you want to do fraud analysis on that transaction before you authorize that transaction, especially in financial sector and telecom. You want to, if you have a captive customer out there standing in front of the ATM or point of sale, you want to be able to make recommendations to that customer in real time based on their transaction profile that you have resident in the database. And we have customers with that use case today. Scoring engine, making offers, making recommendations in line with the transaction is another set of use cases that we are seeing more and more. And then two other aspects of mixed workload that we forget is around, can I manage my database while all these transactions are going on? And for NonStop, the answer is yes. You can change the partitions, you can add columns, you can update the statistics on the database, you can maintain, if your table has become extremely fragmented, you can reorg the table. All those type of database actions, you can do it online. And some of our customers where they have a scenario where they need to do archiving of the data on an ongoing basis, maybe daily or weekly basis, they are doing that as well while the transaction workloads are going on. So we are seeing more and more varieties of mixed workload being executed against NonStop SQL.
Yeah, and I mean, I would guess that's a sweet spot because that's, you know, if I was in the position of looking for a database, that's where I would go for it. I'm going to actually skip to question 6 because it's a kind of an interesting question in a way. When you have a typical RDBMS, the DBA spends an awful lot of time doing tuning stuff. In other words, they're, you know, adding indexes and dropping indexes and so on and so forth to speed up certain kinds of queries. So I was interested in the DBA overhead in respect of NonStop SQL as to how much kind of tuning does the DBA ever get involved in, or how much of it is automatic?
A lot is automatic, and as I said in one of the customer examples, they are managing petabytes of database, 100,000 transactions per second, and this data gets old because they continuously grow. And that's being managed by 2 DBAs, and they meet the SLAs fully, not only for response time, but for availability. The joke is it's 1.5 DBA because they sort of back up each other all the time. But if you look at some of the other clustered database, a lot of DBA time is being spent in configuring the cluster and then distributing the database on top of the cluster and associating it with underlying storage. That configuration task is automated. It's done by the SQL engine. And because we know what are the disk resources available in this cluster, it will spread it across all available resources. It knows we do a B tree, so it knows how to reach the record. You can do your index management online without having to bring down the database. We have the design advisor, which helps the DBA select the clustering tree and makes recommendations. So these are a lot of work that the DBA in other clustered databases do that they don't have to do on NonStop, and hence, in terms of people resources required to manage a very large NonStop database is very low when you compare it with other databases. And that directly contributes to the total cost of ownership. Our claim is that we are the lowest TCO for the mission-critical server environment.
All right. You should probably put that in the presentation. I would like kind of, I mean, I'm going to have to hand back to Eric because we're nearly at the end of my time, but I'd just like you to address the question, which obviously must be in the minds of anybody that goes to HP to look at database. HP's got Vertica. Vertica's very capable column store database. So how would you position NonStop SQL in relation to HP Vertica? And are there instances where you might want to use them both?
Right, we work together. So Vertica has its sweet spot in BI analytics and data warehouse. They have a wonderful write-optimized store and column store to run their queries. What we do is, and some of our customers have experimented with this, they have NonStop SQL as their transactional store and even an operational data store. They have used the plugins that are available from Vertica to move the transaction data to a write-optimized store on Vertica to then run the analytics in real time against the transactional data that is flowing from NonStop into Vertica. So we coexist and complement each other.
Okay, well, Eric, I'll hand it back to you because I seem to have used up my time rather faster than I thought I would.
Yeah, we do have a few questions from the audience, so let me just kind of jump right in here, Ajaya. So one of the questions was noting that, of course, NonStop is not a new product. Can you talk about what has been added to it or amended in the last couple of years?
Last couple of years, a lot. So as I said, we have a very strong roadmap that we have been keeping very busy, and which they love and I love. In the last few years, some of you may be aware that we had a sister platform called NeoView from HP, which was in the space of enterprise data warehousing and analytics. That was before HP acquired Vertica. We are no more selling that platform, but what we have done is we have taken the jewels, the software jewels out of that platform and merged it back into NonStop SQL code base. Now, NeoView itself was an offspring of NonStop SQL over a period of years, and then we were targeting another market with that. So all that code has come back into NonStop and then has been enhanced to support our existing customer base, which has traditionally been using NonStop SQL for OLTP type of applications, but a lot of our customers have been running some very complex OLAP / data warehouse type of workloads on the NonStop SQL. What we do today is we are doing one major release every year of feature function, and then, of course, the defect repairs every 6 months. So we have been coming out on a very predictable schedule for the last few years.
Okay, good. And one of the attendees also writes, and this is what I really wanted to talk about today as well, another advantage of mixed workload would be the fact that you do not have to move data from the OLTP into the data warehouse. Is that correct? And can you talk about the impact of that or the possibilities with taking that kind of approach?
Right. So as I said, that's part of what we can offer with our mixed workload capabilities, because we work with the kernel level scheduler on assigning priorities to every SQL query that comes in. And we can know that this is a short-running query, so it gets the highest priority and is out of the door, which is the characteristics of most of the OLTP transactional workloads. Or if it is a long-running query, maybe doing a sort or a join against a table with 12 billion rows, so it will continue to run at a lower priority so that it does not impact the transactional query response time. And yes, it does save all this data movement. Now, we can do anything with software and with very smart DBAs, but then when you start looking at it in the context of, so what's the cost of replicating this data all across? And it's not a one-time job. There's ongoing licensing and maintenance, and then keeping it available, making sure all the SLAs are satisfied. All of those add up. So you can do it with multi-tier architecture, but those are very complex, requiring a whole set of added resources, people, and systems to deliver the service that you get out of the box with NonStop.
Okay, good. And I went ahead and pushed that slide that Robin had put together, mixed workload versus segregated workloads. And I think you make an excellent point there that the cost of going the traditional route, the segregated route, is an ongoing cost. It doesn't end. Every time you move data around, there's an opportunity for data quality issues to arise. A lot of times you can overwrite good new data with old data. There are lots of things that can happen. So that mixed workload environment can be valuable, but I guess it's not the most common way to do things. Is that right? What kind of traction do you see out there with companies actually leveraging that kind of mixed workload environment in order to avoid these ETL nightmares we're talking about?
Right. So a lot of companies, our customers do leverage it because we make them aware, and then they're like, oh, I can do that. I used to do this type of segregated workload with my other DBMS system, so if I can do this, so it comes as a surprise for them that they can actually do it and do it successfully. And when they talk to existing customers, they see how successfully our existing customers have leveraged this feature of NonStop and NonStop SQL. And it's also a key selling point because today's world, when everyone is so cost conscious about not only the initial CapEx, but multiple systems, multiple licenses, more money, more people to manage, and the IT budgets blowing away because of all of that, and they are under scrutiny now. So when we walk into customers and show the advantage of no complexity, best TCO, we're getting a lot of traction amongst the new customers as well.
That's interesting. It's definitely something that is worthy of exploration, I suppose. Here's a really good question from an attendee. How would you position this product versus something like Vertica?
As a complementary product, we just talked about it, that NonStop does OLTP extremely well. Vertica does analytics extremely well. They have a lot of IP for multiple verticals doing analytics for them. We don't have those capabilities in the NonStop SQL engine. So we work very well together where we can take the transactional data, move it in real time to a Vertica right optimized store, and then the analytics can run against, Vertica does its own magic IP, moving stuff out of the right optimized store and putting a columnar view on that, and then running the analytics against that. So yes, there is some data movement there because there is no mixed workload available outside of NonStop, which can group a NonStop server and a Vertica server from HP and make it transparent. But we do complement each other, and our customers have been using both these platforms from HP to do some great analytics on real-time data.
Okay, good. And do you see use cases around disaster recovery, just obviously in reference to what's happening on the East Coast right now with a tremendous number of people without power, and you have to think that a few servers have been knocked out and maybe even waterlogged. Do you see use cases with disaster recovery for this technology?
Absolutely. So we have a product from HP NonStop Group itself called NonStop RDF, where you can actually mirror your backup, make a copy of the entire cluster, and the switch over to the backup system environment is transparent. You can, there are multiple configurations there where you can run it in active mode or active-passive mode. If you want to run it active with synchronization, we have some of the NonStop partners who offer that value-added product on top of NonStop RDF. And I'm sure when things settle down in a day or two and power starts coming back up, I am going to reach out to our customers on the East Coast and see who stayed up and how had they configured their DR configuration to stay up during this period. But to give you an example, I'm on the Pacific Coast. This is the earthquake zone, and the last few earthquakes, and I'm knocking on wood here, not wishing for another one, The one which happened in San Francisco, I think it was 86, the 93 in LA, our servers stayed up and running. Yes, they had fallen off, but the power was there. Where the power was not there, they went on UPS. When people walked into the data centers 5 days later, they found the servers on the ground, but nobody knew because the transactions kept getting done. So that's the level of business continuity we have.
Okay, good. And I pushed this slide because I think it has a lot of great detail. And there's a very detailed question here I'll throw at you from one of the attendees who asks, what about NUMA architecture that's non-uniform memory access? Is that part of the solution? If not, why not? What is the downside of this?
Right. So today we don't have NUMA on NonStop. So as I said, the NonStop server level, on the processing side, we use the Intel Itanium chip, and then we enhance it with the NonStop architecture. We have our own DRAMs. We have our own solid-state disk. And I say our own. We take the stuff that HP buys, and then we enhance it with the takeover architecture, with the shared nothing architecture, and integrate it with our operating system kernel. Offhand, I can't tell you what the plans for NUMA are, but I can take that as a question and see. I know HP is definitely involved there, but on the NonStop side, I don't have an answer, but can follow up.
That's fine. Okay. And then in an environment where there are multiple databases out there, one of the attendees is asking, can this work well with Oracle, with SQL Server, with other types of environment? I'm guessing yes, at least in terms of the SQL standard, right?
Absolutely. So there are various ways of working with Oracle or with SQL Server. Most of our customers, what they do is they may be using the ETL tools to move data from one database to another. They could be running an app and then using ODBC or JDBC standards to come and access SQLMX. A lot of our customers use Oracle WebLogic Server for their application in app server, and they send access the data over the JDBC driver, put the data on NonStop SQLMX. So many such ways, but all standards-based.
Okay, good. And one last question here. We've gone a little bit long, but we usually do due to the good questions. One of the attendees asks, is there a way to get a better understanding of the footprint for NonStop SQL? In other words, what are the requirements to run it?
A NonStop server, and it can come as our latest server. It's a baby. It's NS2100, and it's a pretty small server, and NonStop SQL will run only on NonStop servers. So our smallest system is NS2100, and our largest system is NB54000. NS2100 is a 4-processing, 4-processor, 4-core system, and NB54000 can go all the way up to 16,000 cores. So depending on workload requirements, you can start small and scale out.
Gotcha. Okay, great. Well, great answers to all those questions. Folks, we will, in fact, archive this webcast. We always do. You can find the archives at InsideAnalysis.com. We're actually busy booking the briefing room for next year right now. We've already booked, I think, 18 or so briefing rooms for next year. If anyone is interested in that, obviously just let us know. And you can see upcoming topics. November is the cloud. Innovators are December. Big data in January. And you can find the editorial calendar on InsideAnalysis.com. Just look under the briefing room. So a big thank you to Ajaya for her time today, and for Robin. Wow, lots of good content here. I think this is something we're going to be hearing about in the future for quite some time. So thanks again for your time. Folks, this ends our event, but we'll catch up to you next time. Until then, take care. And our thoughts and prayers go out to all those folks in the path of Sandy. So we will archive this and send them a link to the archive, and you can share it with your colleagues as well. Take care, folks. Bye-bye.